right, we're going to be looking at section 3.5, which is analyzing arguments with something called Euler diagrams. So we're going to talk about logical arguments, arguments with universal quantifiers, arguments with existential quantifiers. So let's look at this first. A logical argument is made up of premises. And those are just ideas or assumptions or things that are usually held to be true, but not always. And they're made up of conclusions. So together, the premise and the conclusion make up an argument. So sometimes the argument is valid, and if the fact that all the premises are true force the conclusion to be true. But sometimes the argument is not valid, and that's called a fallacy. So let me give you an example of that. So all expensive things are desirable. So that is a premise, and it is a true premise for the most part. I mean, there might be other things that people disagree, but so that is a premise, and that premise is a true premise. All desirable things make you feel good. For the most part, if you desire something, then it usually makes you feel good. So that's another premise. And that is a true premise. So all things that make you feel good make you live longer. And again, there's nothing wrong with that statement. It's a premise. Probably true, because if you feel good, then you feel better and you live longer. So therefore, all expensive things make you live longer. Well, that's not necessarily true. Sometimes when you do have expensive things, they don't make you live longer. So you have a bunch of statements that are true. You have a bunch of premises that are true, but then when you put them together in the end, the final conclusion is not true, and that's a fallacy. Okay, so there's several techniques that we can use to check to see whether something is a valid argument. And one of these is called an Euler diagram, and basically it sort of looks like a Venn diagram. Okay, so let me give you an example of an Euler diagram. The following is the following a valid argument. So all cats are animals. Figgy is a cat. Figgy is an animal. So it appears to be true. So let's look at our Euler diagram. So what we're going to do is we're going to take the fact that where it says all cats are animals, basically we're going to look at the fact that they're animals, and we're going to make our outer circle animals. The inner circle is cats, because all cats have to fall into this animal category. If I did it the other way, it would be saying all animals are cats. All right, Figgy is a cat. So here's Figgy right here in the cat circle. Therefore, Figgy is an animal. So the diagram shows that Figgy is inside the region for animals, and he's inside the region for cats. Therefore, the argument is a valid argument. Okay, so the next example, all sunny days are hot. Okay, today is not hot. So today is not sunny. So let's look at our Euler diagram for that. So again, since the first sentence is talking about all sunny days are hot, hot days is the main topic, and sunny days is a category of hot days. Now that doesn't mean, there are days right here that are hot, but they're not sunny. So we have this example here. It says today it is not sunny. So we put, I'm sorry, I forgot the second sentence. Today is not hot. So I have to put today out here. And so the conclusion is today is not sunny. Well, if X is way out here and sunny is inside the circle, here's our sunny circle right here. And since the X is outside of that part. It isn't a sunny day, so that is a valid argument. Okay, all cars have wheels. Okay, so if we think about that, the main topic, the outer part of the circle, is going to be wheels. The inner part of the circle is going to be cars. So we have this topic out here that is things that have wheels, and inside there we have cars. But what you also have to remember is that there's this little area over here that says toys, and maybe toys is a wagon or something like that. Okay? And then the next statement just says that vehicle has wheels. It doesn't say cars have wheels. So that vehicle could be something out here, maybe a truck, maybe it could be a tractor trailer, maybe it could be a wagon, or that vehicle could be in here under cars. We don't know. So to say that that vehicle is a car would be an invalid conclusion because you don't really know whether or not it is a car or not. All right, so is the following a valid argument? So when they start talking about the word some students drink coffee, so now you're dealing with basically a Venn diagram, if you want to think of it that way, but not all of the students are in the coffee drinker circle. Okay, so let's look at the Venn diagram. So people that drink coffee are over here. Well, students, not all students drink coffee. There are some students that do not drink coffee. So you'll notice that there are some students outside of the coffee drinker circle, and there are some students inside the coffee drinker circle. Okay? And then it says, I'm a student. Well, I am a student, but I don't know whether I fall under the green area where I'm a coffee drinker or the red area where I'm not a coffee drinker. Okay? So given these two statements in the order that they are written, then I cannot place myself in any particular circle. So this is an invalid conclusion. Just because I am a student does not mean I am a coffee drinker. So I hope this helps. Euler diagrams is just an example of something that will help you to determine valid and invalid conclusions. And we are going to keep working, and I hope you have a great day. Thanks.